Okay, this is an AS level biology video about enzymes. And enzymes are proteins. So you should have already learnt a bit about proteins, but I'm going to go over the basics now quickly, so that you know what you need to know for enzymes specifically. So proteins, they have a primary structure first, which is basically a long chain of amino acids joined together by peptide bonds, called a polypeptide. And the secondary structure is when this polypeptide chain is coiled and wrapped around itself. Then the tertiary structure, which is the one you need to know for enzymes, is when ionic hydrogen and disulfide bridges form in the chain. So in the chain will wrap around itself and actually form these ionic bonds, hydrogen bonds and disulfide bridges. And that's what you need to know for enzymes specifically later on. Then for an enzyme, the specific sequence of the amino acids in the primary structure actually affects the shape of the tertiary structure. So the sequence of those amino acids that you have causes a shape, and this shape here is called the active site of the enzyme. And this active site is specific to the shape of a substrate molecule here, and that's called being complementary. So the active site is complementary to the substrate molecule, and you can see that there these will kind of attach together. And when the substrate does attach to the active site, an enzyme substrate complex is formed. You need to know that phrase for many 3-mark or 4-marker questions you'll get in an exam. So, an enzyme substrate complex. Then, using water, the enzyme will actually hydrolyze the bonds within the substrate molecule, and this will form a product. And you know that hydrolysis is the breaking up of the substrate using water. So that's how the enzyme works, by breaking things down, and that's how you digest things in your body. There are 2 theories to an enzyme and how the active site works. The first theory is like the old theory, and this is the lock and key model. And this shows how basically the enzyme and the substrate are fixed positions or fixed shapes, and they will actually fit together like a key fits in a lock. Very simple. Then the second theory is the newer one, called the induced fit model. And this shows that the active site will actually change shape slightly to fit around the substrate molecule. And you can see here it's actually going around the molecule. That's induced fit, and this is a more modern theory, and this shows how the enzyme can actually put pressure on the bonds within the substrate, which actually helps in hydrolysis. So it will actually help to break the bonds when digesting the substrate molecule. So that's quite a good model. That's sort of better than the lock and key model, I suppose. Now I'm going to just talk about how concentration of the substrate will affect the enzyme. So basically you need to know that the rate of the reaction, so the hydrolysis of the substrate into the product, that will happen faster when there is a higher concentration of substrate. And this is because more active sites that are available can be occupied by the substrate molecules. So you'll actually form more of the product faster when all the active sites are occupied. And this happens by increasing the concentration of the substrate. But you need to know that once all the active sites are occupied, the rate of reaction will not increase further. Even if more substrate molecules are added, so if the concentration of the substrate increases, the rate of reaction will not increase. And this is because all the active sites are occupied at one time. So you can't have two molecules in one active site. That doesn't work. You need one molecule per active site. That's how it works. And here there is a graph to demonstrate it. And this is probably a graph you may find in the exam, you might do. So the rate of reactions up here, this is going up, and the concentration of the substrate, this is increasing. So as the concentration of the substrate increases, the rate of reaction will increase. But once the concentration gets really high, the rate of reaction actually stays at one level. So the curve, the shape of the curve straightens off, you could say. And this is where the concentration of the substrate is no longer the limiting factor for the rate of the reaction. Now, I'm going to tell you about temperature and how temperature affects enzymes. So if the temperature where the enzyme is, if that is too high, the hydrogen bonds in the enzyme will actually break. And this breaking of the hydrogen bonds actually, in the tertiary structure, actually causes the sequence of the amino acids in the primary structure to change. So the sequence will change. And this, if you can remember, that affects the active site. This will change the shape of the active site, making it no longer complementary to the substrate molecule. So if the temperature is too high, the active site will change shape and won't be complementary to the substrate molecule. So an enzyme-substrate complex cannot be formed, meaning you can't hydrolyze the substrate and you can't form the product. So the enzyme is denatured. That is another key term you need to know. The enzyme isn't dead. You don't say dead. You say the enzyme is denatured. And that's when the enzyme cannot work anymore because the active site has changed shape and it's no longer complementary. And that's shown here. So here we have the substrate molecule that we had before. The enzyme has changed its active site shape. So they cannot form an enzyme-substrate complex because they're not complementary. And here's a little graph to show that. So as the temperature increases, the rate of reaction will increase, as you know, because of kinetics and more collisions, more successful collisions. If you do chemistry, you'll know more about that. But then as the temperature gets too high, the enzyme denatures, so the rate of reaction falls because you can't form the product. Lastly, inhibitors. So you'll need to know about inhibitors for the exam. There are two kinds of inhibitors that affect enzymes. There are competitive and there are non-competitive. Now, competitive inhibitors, it's basically self-explanatory. The competitive inhibitor will compete with the substrate molecule for the enzyme's active site. So you have to say that this inhibitor has a similar shape to the substrate molecule, so is complementary to the active site, so it will attach to the active site and block the substrate from entering the active site. So no enzyme-substrate complex can form, meaning that the enzyme can't break down the substrate and you won't form the product. That is basically how a competitive inhibitor works. Competitive inhibitors are normally seen to be as bad, but they don't have to be bad because some antibiotics actually work using competitive inhibition. Because they will actually, most antibiotics do have a similar shape to a lot of bad substrates that will create bad things for your body. So if you make an antibiotic that has a similar shape to that substrate, it will attach to the active site and block any bad substrates from entering the active site, and so no bad products will be formed. So that's how quite a lot of antibiotics work. The second inhibitor is called a non-competitive inhibitor, and this works in a similar way to how temperature affects enzymes. So the non-competitive inhibitor, it doesn't compete for the active site, it actually attaches itself onto the outside of the enzyme in a different place to the active site. And what it will do there is it will actually break the hydrogen bonds within the enzyme, changing the shape of the active site, so the active site is no longer complementary to the substrate molecule, meaning an enzyme-substrate complex cannot be formed and the enzyme is denatured. So that's very similar to how temperature works on enzymes. You just have to remember that very simple order of events. So changes shape of the active site, no longer complementary,